Hey there. Excuse the lack of a haircut, but that's the way it goes this time of year in our situation. We need to talk about graphing trig functions. It's an important thing. I do it all the time. It's not in the books. It's not in the books the way I do it. So you might remember that what I do is I make the grid, and I made the grid in advance just to save the time from having to watch me make the grid. And what we're going to do is take a typical sine function or cosine function. They're the same graph, and that's the thing that the books aren't emphasizing enough. So let me do this. Let me show you what the graph looks like. We have a starting point that's in red there, and then it swings on up, and it's almost horizontal when it comes up to the top there. And then symmetrically, I'm hand drawing, so it's not really symmetric, down back to the baseline. And then it's still the same curve. You could go to Home Depot and order 4 of these and just put them in different things, like if you were doing a garden border or something. And finally, we come back up to where we started. So there's one period. And this looks kind of sine-ish, but you don't know, because I haven't told you where we started. So you have to know where the x starts is. That's the phase shift. And you don't know also how high this is, because that's the upshift. So the general form here is kind of complicated, and so we're just going to tease it all out. Let's look at y is equal to a times, it's going to be something complicated, sine of something. Remember, do the parentheses first. And in the end, we're going to add something to that, so I'm going to call that c. And inside the parentheses, there's another set of parentheses, because we have to separate out the phase shift from the change in period. So I'm going to use a period of p. I don't, call me crazy. And then the phase shift is going to be inside parentheses. It's important that you separate this p out, because otherwise you're not going to get the right phase shift. Okay, so I wrote the wrong thing. You'll live with it. So here's our general thing. We've taken theta, the angle, we've phase shifted it by s. We've multiplied that by p. That means we're going through p times as fast. We multiplied that whole thing after taking the sine by a. That's a stretch, and then we add c. And a good mathematician does the graph first and then the axes. So now we're going to put in the axes. So we're going to start with kind of where the baseline for all of this is. And the baseline is what we've done. Ordinarily, sine starts at, sorry about the shadow, sine starts at 0, but now we're adding c to everything. So when sine goes up to 1, we would be at c plus 1. When sine goes down to minus 1, we'd be at minus 1 plus c. So this horizontal line right here is where y is equal to c. There we go. And the amplitude is probably the next easiest one to see. It's the height that the wave goes above the base. So the amplitude is not the whole grid, but the upper half of the grid. So that's what's going on there. The next thing I think is to do the phase shift, and the phase shift says this is where everything happens. And you can remind yourself about this. So I put the phase shift here. In this formula, when theta is s, you're taking sine of 0. Now that's where sine starts. So you've got the correct phase shift there. And finally is the period. Now the ordinary sine function has period 2 pi, but we're going p times as fast. So that makes the period 2 pi divided by p. So that's about the whole thing. We've got a as the amplitude, and the next thing that we'd bump into is p. That tells us the period. And then the phase shift. This is just reading left to right. tells us where it all starts, and C tells us how far it all goes. So we did the graph, and then we did the parentheses, and you can almost do this and label everything, the C and the amplitude and the period and the phase shift in pencil. If you need to do another one, you could just do the other one in pencil. So there's the deal. A couple of important things to remind you of is, hey, what about cosine? Well, you know what? Cosine of theta is the sine of pi over 2 minus theta, which is minus the sine of theta minus pi over 2. So cosine theta, we're going to flip things and then have a phase shift, or have a phase shift and then flip things. So so the cosine theta would probably be starting about here, but it would be flipped. So we can handle cosine that way, so that's not too much of a mystery. The other thing is this enables us to handle all kinds of things. I'm not going to put this down directly. It's in a separate video. But the thing is, if we have A times sine of px plus B times the cosine of px, this is a typical thing that comes out of a lot of engineering and electrical engineering problems, is you get a solution function that looks like this, and we know, using the addition laws for sine and cosine, how to rewrite this as a new amplitude, and the period stays the same, but we'll have a phase shift. So we've handled everything that looks like this. These are called linear combinations, and we've handled those as well. Same grid, same graph, different labels. So keep that in mind as you have to graph a lot of trig functions, and enjoy.